Okay, welcome to Chapter 6, Part 2. We are going to be looking at if-else, control structures, we're going to be looking at Boolean functions, and we're going to just be dealing with one condition, thus the single condition idea. So, it is time to start thinking about more advanced worlds, and it's time to start thinking about your final exam project. So, there's something, as you get into games, as you know, there are decisions involved. Should I click here? Should I not? Should I go this way with my car, whatever. So decisions need to be made, and you need to be learning how to code those kind of decisions. So here's a pretty straightforward example. If you had a race car simulation, the driver would need to steer the car around the curves and pass different mile markers. And as long as the car stays on the road, the score increases. If it goes off the road, the car crashes and the game might end. And if the driver gets the car over the finish line, that time is the winning, or is the final time, and the driver may or may not win. So when we're talking about a decision, it's always based on current conditions, right? Is the car on the road or not? So we're going to check it using a true-false, a logical expression with a true-false answer. So if the car's on the road, that's true. If the car's over the finish line, well, that might be false. So those are the kind of questions your code needs to be constantly asking. Is it on the road? Is it over the finish line? So we start to talk about if-else and drawing it out like this. Decision maps is one word for this. So is the condition true? If it is, then you do this. If it's false, do something else. We've talked about this a little bit, but we're really going to be using it a lot more. Especially because we're going to be using it in functions. We've used it in methods a little bit, now it's time to use it in functions. So here's a Boolean function. Let's suppose that you want to build a game that's going to help train air traffic controllers. So the air traffic controllers need to be watching out, we hope, for possible collisions in the space. In this case, we have a biplane, you've seen that before, and a cute little helicopter, and we want to make sure they don't crash. So here's your challenge. The factor that you're going to consider is what's the vertical distance between them, right? The difference in heights. If the difference in heights is 0, that's a problem. They're going to crash. So can you write a function that decides if there will be a collision? What do you need to check? I'd like you to try it. Here's some hints first. You're going to want to use a world level relational operator. So you go on world and function, I think, and check it out there. You might even want to use an absolute value function. And then, if you really want to get snazzy, once you figure it out, can you add parameters? So please pause this. Just spend about 5 minutes. It doesn't matter what the objects actually are. Just throw, a penguin and a bunny and see if they're going to crash. So pause, try it out, and come back. Okay, hopefully at this point you have tried it at least. Whether or not you solved it is a different thing. So you needed to check the vertical distance against a minimum difference in altitudes. And that minimum difference has to do with how tall the objects themselves are, right? So hopefully your function returns true if they're too close, otherwise false, or something like that, but you're measuring is it too close. I'm going to show you what happens if our function returns true if they're too close. Okay, so this is just the function. It's not even a method that uses it yet. I just want to just start off by showing you this. So here's what we just talked about. If the absolute value of aircraft 1, and so these are parameters, aircraft 1 and aircraft 2, if the absolute value of it is less than a minimum distance, then it's returning true. What it's asking is, are they too close, right? So are they too close? I want to show you really quickly how to program this. You know how to deal with the if-else, but it's the absolute value that might be a little bit tricky. If you go to World, click on World, go to Functions, and you just keep going down, and it's under Advanced Math, and you bring in absolute value. And if you did this, it would ask you about, well, I accidentally just did absolute value, but you would fill in these this information as well. All right, so let's go talk about what concepts are used with this and how to make a method with it. Okay, so we've talked about this under functions. You go down to math, and that's obviously how you get the less than the minimum distance thing, but we also talked about the absolute value function as well. Okay, so now to make a method. How do you avoid a collision? What should the aircraft do? Which one? Now it's important. So what they decided is, let's try the aircraft that's above the other should move up. So the higher one should move up and the lower one should move down. That makes sense. But you really want to make sure that you're clear on which is which, right? So that the wrong one doesn't move. So let's take a look at that. Okay, so this is actually really simple code that has not such a simple idea. Let me play it for you first, and then we'll talk about it. So I hit play, and it doesn't even, it's not even that interesting. You just see the helicopter go up and the biplane goes down. Okay, and if you look at, so one more time, sorry. The helicopter goes up. Okay, so let's take a look at the code. And it just says if, now this is the function we looked at before. So if biplane, if they're too close, that's what it's doing, then you go to the method to avoid collision. Now part of it is you need to figure out who is higher than the other one. And you don't actually have to do it, the code's going to do it. So the question again is if aircraft 1 is above aircraft 2, then 1 moves up and 2 moves down. Otherwise, vice versa. Okay? So let me just play with this a little bit and change it up. So let's make the biplane go up. Oops, sorry. Let's make the biplane go up. So clearly this is going to be above the helicopter, right? And if you hit play, now it should switch. So this is pretty clever code. You've seen the function before. And hopefully you know how to do this. This is a little minimum function itself. We'll take a look at, sorry, let me scroll this over. Hopefully. Sorry about that, my brain paused for a second. I was trying to show you the function to fill in here. Now these are parameters, so obviously you're not going to find anything here to click on. So I just chose one. Let's choose biplane. And you go down to biplane is above. So if I dragged that in instead, right? And I could say it's above the helicopter, and then you drag in your parameters to make that happen. So one more time, just take one more look at it. It's pretty clever. So if it's too close, here's that function we talked about before. If you don't remember it, go back and look at it. And then it calls this method. And you'll notice that if the else is, that's empty, and there's no problem with that. Okay, so going back to our conclusion. Okay, so what was illustrated in this last example? You had a decision to control whether a method was called or not, and also the decision was to determine which set of instructions are immediately executed. That's chimed in with the instruction, the method, and it's all based on a function. So the functions were asking a question, and it was actually asking two different questions. The first question was, are they too close? And then the second question was, which one is above the other? So like I said, not that many lines of code, but a lot going on. Okay, that's it. Happy functioning.